Hello, this is Jordan and Alper, team project for the hackathon that today we're going to be demonstrating the use and functions of spaCy. It is a open source library that is a natural language processing that we can do in Python, similar to some of the other NLPs that we discussed in the class in prior ICPs. So here is our source code. We use a So we are going to be extracting text from a PDF. We use a library called PDF Miner, which will take the text from the PDF and it will convert it into text that will make it readable through spaCy. Here we are importing spaCy, and we are also loading the English tokenizer, tagger, parser, NER, and word vectors into the NLP. And here is where we have extracted the PDF text. From spaCy, we are importing phrase matcher, which in this situation, we have a terminology list that includes some key phrases from the PDF file. To give a little context, the PDF file that's been uploaded and is also available on the GitHub link talks about the main topic is about the opioid epidemic. So we look for keywords such as drug, overdose, death, for example, and we will parse through the text document and see if any of these three keywords show up in the text document. So here we created a counter for each of those specific words. And here we are parsing through the text file. And if any of those three words show up as it is parsing through each word, we will increase that counter by 1. And here we are printing the results of that. So I'm actually going to run this program, and it'll actually do the next part that I will describe in a little bit once this part runs. Okay, so as you can see, we have shown through the text document the word drug appeared 107 times, the word overdose appeared 51, and the word death appeared 50 times. The next part, we do two types of tokenization. One is for noun phrases. So it parses through the text file, and any phrases that are nouns, it will output those specific phrases. So morbidity weekly, illicit drug use disorders. So it's not just the individual noun words, but it groups entire noun phrases. And here we are doing tokenization for verbs that appear in the text document. And as you can see in the output, be publish, result, include, for example, will show up as some verbs that are within the text file. And last but not least, we will use spaCy to separate the text file into separate sentences. Um, for example, drug use, etc., etc. That's one sentence, and then another sentence, another sentence. And the way it works is spaCy will recognize different punctuation marks, periods, exclamation points, question marks, and colons, for example, and are able to determine groups of sentences. It works well for plain text, but as you can see in the code, it gets a little more difficult, as you can see in this part right here. In the actual PDF file, you can see there's actually parts where it shows uh, graphs, some tables with some numerical data, which is pretty common in many scientific research papers. So the it separates it separates them, but it's not as pretty. Well, anyways, that is just some demonstration of some of the key functionalities of spaCy and potential applications of this library. Thank you.